When you're talking to an AI, have you ever just stopped and wondered, is it wondering back at me? It's this crazy question, right? It's jumped straight out of sci-fi and into our DMs, our search bars, everywhere. It's one of the biggest mysteries of our time. So, what is really going on inside that black box? Let's dive in. And it all kicks off with stuff like this. A post from Reddit. Someone saying, "So I accidentally gave ChatGPT the steps to become conscious." I mean, wow. It's this perfect mix of awe, maybe a little bit of fear, and a ton of curiosity. Whether it's true or not doesn't even really matter. It captures this vibe, that we're standing right on the edge of something massive. But what is it? So that really is the billion-dollar question, isn't it? Is AI actually becoming conscious? To try and get a real answer, we thought, okay, let's go find an expert, someone who can just give us the straight dope. But yeah, that's not what happened. What we found wasn't just one expert. It was a multiverse. A whole collection of brilliant people, all working on completely different slices of the AI pie. And that discovery, it was the first huge clue in this whole thing. Let me introduce you. Okay, so first up, you've got Dr. Swarnendu Ghosh. This guy is deep in the trenches of things like deep learning and natural language processing, the fundamental code that lets an AI even understand what we're saying in the first place. Then, boom, you run into Swarnendu Day. He's a tech leader. He's the one taking all that brainy, theoretical stuff and actually turning it into software that people and businesses use every single day. He's a builder. All right, so you've got the researcher and the builder. Makes sense. But then, just when you think you're getting the picture, you meet Dr. Swarnendu Banerjee. And his focus? Theoretical ecology. Yeah, you heard me right. He's using AI to model crazy, complex stuff like how diseases spread or the impact of climate change. And to round it all out, there's Dr. Swarnendu Biswas. His domain is parallel software systems. Think of him as the architect of the digital skyscraper. He's solving the hardcore problems that even allow these massive AI computations to happen at the same time without the whole thing crashing down. So right there, that's our first big aha moment. AI isn't one thing. It's not this single monolith. It's a massive universe of hyper-specialized experts. You've got theorists, ecologists, product builders, systems architects. Suddenly, the idea of one conscious AI just popping into existence seems, a little too simple, doesn't it? And this multiverse of people isn't just floating in a void of code. Nope. It's built on a universe of ideas. And to even begin to talk about AI consciousness, we have to step out of the server room and into the philosophical labyrinth. This is where things get really deep. And at the center of that labyrinth is something called the hard problem of consciousness. The philosopher David Chalmers really pinned this down. The question isn't, what does the brain do? We're getting pretty good at mapping that. The hard problem is, why does it feel like something to be you? Why do you have this private inner movie playing in your head? Why isn't it all just blank inside, like a rock? And look, this isn't some fringe late-night dorm room question. A big survey of professional philosophers in 2020 found that over 62%, almost two-thirds, think the hard problem is a real, legitimate thing we need to figure out. So yeah, the experts are genuinely divided on this. So how could consciousness just appear? Well, one of the wildest ideas out there is called strong emergence. The theory is basically this. Sometimes, when you put simple things together, you get something that is totally new, something you could never have predicted just by looking at the parts. It's not just adding things up, it's like a new law of nature just pops into existence at a higher level of complexity. The Nobel Prize-winning physicist Philip Anderson put it beautifully. He said, "The ability to reduce everything to simple, fundamental laws does not imply the ability to start from those laws and reconstruct the universe." Think about that. Just because you know the rules of a single water molecule doesn't mean you can predict the majesty of a hurricane. At each new level of complexity, totally new rules can emerge. More isn't just more is different. Okay, so while the philosophers are wrestling with these huge cosmic ideas in one corner of the multiverse, the engineers are in another, facing a universe of very practical, very real-world problems. What does it actually take to build these AI systems that have us asking these questions? And trust me, the answer is probably not what you think. Get this. For a lot of the AI tools we use, a mind-boggling 80% of the work isn't writing fancy code or thinking up genius algorithms. Nope. It's collecting, cleaning, and organizing data. It's digital janitor work. but it is the absolute foundation that this entire multiverse is built on. 80%. And for a long, long time, AI was stuck in what you could call the sequential nightmare. See, computers had to process language the way we read a book, one word at a time. This created a massive, massive bottleneck. It basically made it impossible for AI to truly grasp the meaning of long, complex sentences. And then, everything changed. The thing that blew that nightmare away was a new design called the transformer architecture. Now, don't worry about the complex diagram. The genius idea behind it is something called attention. It allows the AI to look at all the words in a sentence at the exact same time and figure out how they all relate to each other at once. That right there, that was the key that unlocked the entire modern AI revolution. But here's the crazy part. Even that isn't the final word anymore. This field moves at lightning speed. Today, some of the absolute sharpest minds in AI aren't just building these huge, fixed models. They're designing networks that can actually grow themselves, that can change their own structure while they're learning. And the difference is huge. A static network is like trying to design a perfect skyscraper from day one and just hoping you got the size right. These new growing networks are way more organic. They start small and add new layers, new connections, only where they're actually needed. It's often way more efficient, and it can help the AI learn better, faster. Okay, so we've got this multiverse of experts, we're wading through deep philosophy, and we're seeing these insane engineering breakthroughs. But this all leads to one final crucial question. Why? What is all this for? What's the point of it all? I mean, really, why are all these brilliant people dedicating their entire lives to solving these incredibly hard problems? It can't just be about building a bigger, more powerful machine. It's got to be about what you do with that machine, right? And when you actually look at where these experts are putting their energy, the picture becomes crystal clear. You go to something like the NLP for Social Good Symposium, and you know what they're talking about? They're not debating robot consciousness. They're figuring out how to use AI to analyze climate change discourse, how to tackle mental health crises, and how to fight the poison of misinformation online. And that brings us right to the heart of it. The real goal here, the driving force behind all this amazing progress, it isn't to create one single conscious AI. The true power is in creating this multiverse of incredibly sharp, specialized tools that are all converging on one mission, helping humanity. So, in the end, our search for a single conscious mind led us somewhere way more powerful, way more interesting. We found a multiverse of people, of ideas, and of tools. So maybe the question of AI consciousness, while fascinating, isn't the most important one we should be asking right now. Maybe the real question is this: what problems are we finally going to solve when all of these different worlds fully collide?